Hello, hello. Here we go with some more geometry. It's super exciting. Although today's probably will maybe be a little faster for you. I'm not sure, but hopefully it won't be too bad. So let's just get started. Section 10.4 on page 704. Okay, 10.4 on 704. So the first thing we're going to do in this section is we are going to do example 1 and learn about how to get the area of a completely strange and weird looking figure. Remember we did composite figures where we could cut them into different shapes that we knew how to do and then get those and add them all together. Well, today it's a completely weird, as you can see example 1, it's just like a squiggly thing. And we're supposed to get the area of it. So basically all you do is this. If it's like a squiggly, like weird thing like this, you just have to find, they've made a grid right for you, okay? However their grid is, you're just estimating, right? You're just estimating. So for example 1, I know my shape is nothing like their shape, but I'm going to show you how to do it with mine. You just estimate and count like the in full boxes, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And then you can just kind of go like, oh, well, those two make 28. Those three make 29, 30. That's almost 31. I could count it with that one. 32, 33, 34. I'll just use this one to make up the extra for that. 35. Those two would make 36 and maybe 37. And say, oh, that's about 37. About. Okay? And just do it that way. So for those, you may have a totally different answer than somebody else does by, a couple, because you estimated it a little differently than they did. So just kind of count the full squares and count the partial squares to make up the difference and give me that number. That's all you have to do for those. Okay? Example number 2, draw and classify the polygon. So they'll give you the vertices and you're going to need to draw. Yes, you're going to have to draw it. Draw it on your paper. So they have one that looks like this, and then it looks like they gave you kind of a rectangle. It looks like this. And they want you to find the area and the perimeter. So you're going to find the perimeter and the area. Remember, perimeter is distance around. Hey, guess what? This is kind of a diagonally looking line. You're going to have to use like the distance formula to figure out what it is, because it's not straight up and down, because they love you and they wanted to give you that special extra work to do. So just do the distance formula, or you could maybe divide it into a triangle and do Pythagorean theorem at some point. It's up to you. You're just going to have to figure out ways to find the missing sides, and then you can add them all together. Okay? And then once you have the sides, you could also do the area. All right, so basically you're going to have to graph it and give that information to me, and then also give me the perimeter and the area. So your picture that you turn in is going to look something like this with some numbers on it as well. Okay, and like I said, you're going to use the distance formula, or divide it into triangles and use Pythagorean theorem, whatever you want to do to get the missing parts. Okay, and then on example 3, sometimes it's too hard. There's a shape and it's just too hard to figure out the area of that shape, so it's easier to take the shape they gave you. I'm going to draw it kind of here, right? It's easier maybe to make a box around it. Like this. And since I know that this is a triangle here, and this is a triangle, and this is a triangle that are all straight up and down, so it's much easier. You can just do base times height divided by 2. For me, I would take the area of this whole thing and subtract each of the triangles to be left with that. And that might be easier. You could actually do those maybe for example number 2 as well. Okay, so it might be easier to draw a box around it because it's just straight lines, super easy to just count it on the graph. Then find the area of each of these shapes and subtract it out, and you'll be left with the one they're looking for. Just make sure when you do your box that you touch the vertex. Otherwise, it's not going to be correct. You have to make your box touch each vertex. Okay? So that's how you would do ones like example number 3. Example number 4, we're not going to do any of example number 4. So when you get to your assignment, you're not going to do the matching ones, which would be like 9 and 18. We're just going to completely skip those altogether. Okay. So I think this will be not too bad for you, just maybe a little time consuming with these shapes and having to find a bunch of areas to subtract some other ones out. But if you have any questions, as always, please let me know. I'm sad that we're not together because some of the stuff that we do at the end of the school year is much more fun than some of the other stuff, like proofs and whatnot. So that's but it's easier for you to learn at home, so it works out okay. I'll give you a little math humor from the book before you go. See, if you don't watch these videos, you don't get these amazingly awesome jokes at the end. Question: what happened to the plant in the math classroom? Yeah, it has nothing to do with anything that we're doing today. I know you're looking through there. What happened to the plant in the math classroom? Are you ready? I don't think you are. It grew square roots. Okay. We'll see you guys next time. Bye.